What we're going to be working on right now is solving quadratic equations by factoring, doing some examples. So we'll start with this one. Negative 28x equals 16 minus 8x squared. And before we can solve an equation by factoring, what we're going to want to do is get the equation equal to 0. And we also want to write it in standard form. So I'm going to go ahead and move my negative 8x squared to the other side of the equation, because when I'm factoring, I always like to start out with a positive leading coefficient. I'm also going to subtract that 16 from both sides to move that term to the left side of the equation as well. So I'm going to start out with 8x squared minus 28x minus 16 equals 0. So I have it equal to 0 and in standard form. Then I'm going to look for greatest common factor. All of those terms are divisible by 4. So I'll put the 4 out in front, and I'm left with 2x squared minus 7x minus 4 equals 0. I'm going to continue factoring that quadratic trinomial. Let's see. It's a trinomial, so I'm going to use guess and check. I know the leading term is 2x squared, so first times first has to be 2x and x. The negative at the end tells me that my signs are going to be opposite, and I'm looking for the outside terms and the inside terms to give me a difference of negative 7x. So my possibilities for the last times last would be 1 times 4 or 2 times 2. If I use 2 and 2, I'll end up with 2x times 2 will be 4x. 2 times x will be 2x. The difference is only 2x. If I put a 4 and a 1, I would have 8x and x, so that's going to work. So we'll have a 4 here, 1 here. The outside terms multiply to give 8x. The inside terms multiply to give 1x. Since I need negative 7x, the 8x needs to be the negative, so it will be x minus 4 times 2x plus 1. The next step in solving by factoring, after I have it factored, I'm going to use the zero product property that says when I have a product whose result is 0, then one of the factors that are multiplied has to equal 0. So if I look at this equation, I actually have 1, 2, 3 factors. Remember, a factor is something that's being multiplied. So I have 4 times the parenthesis 2x plus 1 times the parenthesis x minus 4. But we are not going to set that 4, that greatest common factor, equal to 0, because remember in our steps we said earlier that we set each part, each factor that contains a variable equal to 0. So I'm just going to make myself a note. That is, do not set constant factors equal to 0. And a constant factor is a factor that does not have a variable. So I will go ahead and set the 2x plus 1 equal to 0 and the x minus 4 equal to 0. And subtract 1, so 2x equals negative 1. Divide by 2 gives me x equals negative 1/2. And then the other one, add 4, gives me x equals 4. Now when we finish solving a quadratic equation, or any equation for that matter, we should go ahead and check our answer. And we check that answer by substituting those values into the original equation. So we'll need to check in that equation, negative 28x equals 16 minus 8x squared. We'll want to check x equals negative 1/2 and x equals 4 to make sure we have the right solutions. So we'll do negative 28 times negative 1/2 equals 16 minus 8 times negative 1/2 squared. We need to follow the order of operations, so I will be squaring that negative 1/2 first. So negative 28 times negative 1/2 equals 16 minus 8 times negative 1/2 times negative 1/2 is positive 1/4. Next, I will multiply and divide left to right. So I'll have negative 28 times negative 1/2 is positive 14 equals 16, and then negative 8 times 1/4 is minus 2. And since 14 does equal 16 minus 2, that is a correct solution. I will do the same thing with x equals 4. So negative 28 times 4 equals 16 minus 8 times 4 squared. Negative 28 times 4, well, I know that 20 times 4 is 80 and 8 times 4 is 32, so that's negative 112 equals 16 minus 8 times 4 squared, which is 16. Let's see, 8 times 16 is 128, so we have negative 112 equals 16 minus 128. And then you'll want to double check to make sure that 16 minus 128 is negative 112, which it is. So we've checked both solutions, so I can say that the solutions to that equation are x equals negative 1/2 or x equals 4. Let's look at another example here. Oh, before we do that, let me give you a secret question. Your secret question is solve 300 equals negative 5x squared minus 80x. So if you are answering secret questions, go ahead and solve that. Pause the tape, solve that equation, and then if you have questions about it, go ahead and send me an email or write it down so that we can look at that together in class. Okay, and then we'll go on to our next example. 7x squared equals negative 175. In order to solve this quadratic equation, we first want to start with it equaling 0. So we will add 175, add 175. So we have 7x squared plus 175 equals 0. The next step is to factor, and we start doing that by looking for a greatest common factor. 175 is divisible by 7, so we will factor out a 7, and that will leave us x squared plus 25 equals 0. We want to look at the structure of this quadratic binomial. Since it is a binomial, we really have 4 choices. We have sum of squares, difference of squares, sum of cubes, or difference of cubes. Since it's addition, I know it has to be sum, and this term x squared is a perfect square. This term 25 is a perfect square. So it is f squared plus l squared, which factors into f plus li times f minus li. Then I want to figure out, since f squared is x squared, that tells me that f is going to be x. And since l squared is 25, that tells me l is going to be 5. Then I'll go ahead and factor x squared plus 25 equals 0. So I have 7 times f plus li, so x plus 5i, times f minus li, or x minus 5i, equals 0. Now that this whole thing is factored, I can use the zero product property. Zero product property says that when I have factors multiplied by each other and the result is 0, that means that one of those factors had to be equal to 0. I am not going to set 7 equal to 0 because it's a constant factor. I am going to set x plus 5i equal to 0, and I am also going to set x minus 5i equal to 0, and I will solve those using regular algebra methods. So x equals negative 5i, x minus 5i, so I add 5i to both sides, and x equals 5i. And those are my two solutions. X equals 5i, x equals negative 5i. Now we could check those solutions in our original equation 7x squared equals negative 175. X equals negative 5i would be 7 times negative 5i quantity squared equals negative 175. I will apply that exponent first, so that would give me 7 times negative 5 times negative 5 is 25. I times I is I squared equals negative 175. Now remember that I squared is equal to negative 1. So really in this parenthesis I have 25 times negative 1. So 7 times negative 25 equals negative 175. And that is true. When I check x equals 5i, I have almost the exact same problem. 7 times 5i squared equals negative 175. So I do 5i times 5i, I get 25i squared equals negative 175. And then 25i squared would be the same as 25 times negative 1. So 7 times negative 25 equals negative 175. So that also checks out. Let's look at just a couple more examples just to make sure we know what we're doing before we get too far down the road. Just 2 more examples here. The first one is going to be x times x plus 12 equals negative 20. Now remember when we first started out, the very first step for solving by factoring was that you wanted to get your equation equal to 0, and you may remember me saying that sometimes you might need to FOIL or distribute to get rid of parentheses. Well, this is one of those times. We're going to want to distribute this x into both terms so that we end up with without this multiplication going on. So x times x will give me x squared. X times positive 12 plus 12x equals negative 20. And then we're going to need to add 20 to both sides so that we get the equation equal to 0. So now we have x squared plus 12x plus 20 equals 0. And we can go ahead and factor at this point. We want to check to see if there's a greatest common factor. And the only factor they have in common in this equation is a 1. And since a greatest common factor of 1 isn't going to help us in factoring, we'll just leave it. And we'll start our guess and check. 3 terms with a plus at the back tells me the signs are going to be the same. And since this middle term is positive, they're both going to be plus. First times first is x squared, so there's only one possibility, x and x. Last times last is 20, so it could be 1 and 20, 2 and 10, 4 and 5. And then I'm trying to add the outside and inside terms to get positive 12x. So it looks to me like 2 and 10 are going to do the trick. And then I will use the zero product property that says I have 2 factors, x plus 2 times x plus 10 equaling 0, means that either x plus 2 has to equal 0 or x plus 10 has to equal 0. Solve those using ordinary, everyday algebra to give us the solution x equals negative 2 or x equals negative 10. You can, of course, go back and check those solutions to make sure that how you're solving them is giving you correct solutions. I'm going to skip that on this problem so we can get on to this last example. X cubed equals 16x. And we'll want to start that the same way. We need to get that equation equal to 0. Since I like to start out with a leading term that is positive, I will subtract the 16x from both sides so that both of my terms end up on the left side. I have x cubed minus 16x equals 0. And then I'm going to factor. So when I factor, I start by looking for a greatest common factor. Both of these terms have an x in them, so I'll take an x out front. X times x squared minus 16 equals 0. I want to check in this parenthesis and see if I can factor any further. It is a binomial, so I've got those 4 formulas to think about. Sum of squares, difference of squares, sum of cubes, difference of cubes. The x squared is a perfect square and the 16 is a perfect square, and I have subtraction. So it looks like difference of squares, so f squared minus l squared, which factors into f plus l times f minus l. First times first is x squared, which tells me that f is x. Last times last is 16, which tells me that L is 4. I'm going to factor this into x times x plus 4 times x minus 4 equals 0. And it's time for the ZPP, zero product property. This time I have 3 factors again, x, x plus 4, and x minus 4. You want to be careful because all the ones we've had so far, that greatest common factor has just been a constant term, has not had any variables in it. This time, our greatest common factor does have a variable. So we have 3 parts for the zero product property to set equal to 0. We've always been working with x plus 4 equals 0 and the x minus 4 equals 0, but this time we also have this x out in front. So we just set that equal to 0, x equals 0, and we automatically have one of our solutions will be x equals 0. Then the second solution, subtract 4, will be x equals negative 4. And then add 4, x equals 4. So we have 3 solutions to this equation, x equals 0, x equals negative 4, x equals positive 4.